See this problem. Verify Green's theorem in the plane for interval 3x square minus 8y square dx plus 4y minus 6xy into dy, where C is the boundary of the region defined by y equal to root x, comma y equal to x square. Say that for y equal to root x, we have to draw a curve. For that, put x equal to 0, then automatically y equal to 0. Then put x equal to 1, then y equal to root 1 is equal to 1. Put x equal to 2. The value of y equal to root 2 equal to 1.414. Then put x equal to 3, y equal to root 3. You may have different values for x and y. Using these values, draw a curve. We can get the portion of this curve like this. Here we can get, using these values, 0, 0, this is origin, 1, 1, then 2, x equal to 2, y equal to 1.414. If you use these data, and we can get this portion of the curve. If you put x equal to -1, -2, -3, we may get different y values. For that, we can get the another one portion. So for the y equal to root x, y equal to root x means y square is equal to x. We can get the curve like this. This is the parabola we can get for y square is equal to x. In the same manner, if you utilize the second equation, y equal to x square, then here put x equal to 0, automatically y equal to 0. Then the points are 0, 0. Put x equal to 1, y equal to x square, that means 1 square 1. We can get the second point, 1, 1. Put x equal to 2, then y equal to 2 square, that is 4. 2, 4. We can get different points. Using these points, if you draw a curve, we can get this portion, parabola. Then for the negative values of x equal to -1, we can get y equal to +1. X equal to -2, we can get y is equal to 4. This is 1, -1, 1. This is -2, 4. We can get this portion. Therefore, for y equal to x square, we can get this parabola. For y square is equal to x, which means that y equal to root x. In our problem, they have given y equal to root x. For y equal to root x, we can get this parabola. For y equal to x square, we can get this parabola. These two parabolas are intersecting at 2 points. One is at the origin and another one point is A. In between these two intercepts, we can get a region, that is R. This is a region bounded by these two parabolic paths. With the help of these two parabolas, we have to fix the values of x and y, lower limit of x and upper limit of x, lower limit of y and upper limit of y. Now we should fix the lower and upper limits of x. To fix the lower limit of x, draw a strip parallel to the x-axis in the region R. Say this is the strip I have drawn from the origin to maximum value. The starting point is lower limit, the end point is upper limit. The starting point corresponding to the curve y square is equal to x. So the lower value of x is y square. And the end point of the strip is in the curve y equal to x square. Therefore, the lower limit of x is root y, because the end point touches the curve x square is equal to y, y equal to x square. Therefore, x square is equal to y, and x equal to root y. This is lower limit, this is upper limit. But in our case, the lower value of y is 0, upper value of y is 1. So the limit values of x are 0 and 1. Now come to our y, upper limit, lower and upper limits of y. To find the lower and upper limits of y, we have to draw a parallel line, a line parallel to y-axis. We can construct a strip parallel to the y-axis. This is the starting point, this is the end point. From origin to maximum value, we have to draw the strip. That strip should be parallel to the y-axis because we are going to find out the lower and upper limits of y. See, the lower limit starts from the curve y equal to x square, and the upper limit touches the curve y square is equal to x. Therefore, the lower limit of y is x square and the upper limit is y equal to root x. See here, y equal to root x. In this way, we have fixed the lower and upper limits of y. Now come to our problem. Given is m into dx plus n into dy, which is equal to 3x square minus 8y square dx plus 4y minus 6xy into dy. This is given. Now the value of m equal to 3x square minus 8y square. Then the value of n is 4y minus 6xy. You know the Green's theorem, m into dx plus n into dy equal to double integral of r dou n by dou x minus dou m by dou y into dx dy. Then find out the value of dou m by dou y. Just to differentiate this with respect to y. 3x square differentiation is 0. If you differentiate this, you can get minus 16y. Then find out the value of dou n by dou x, which is equal to minus 6y. Then dou n by dou x minus dou m by dou y, which is equal to minus 6y minus of minus 16y, which is equal to minus 6y plus 16y, which is equal to 10y. Now the integral m into dx, the value of m is 3x square minus 8y square into dx plus integral n 4y minus 6xy. y minus 6xy into dy equal to double integral of, here we have to put the lower and upper limits, x equal to 0 to 1, then y equal to lower limit x square, upper limit root x. The value of substitute this value, dou n by dou x minus dou m by dou y into dx dy. This is 10y into dx dy. This is equal to 0 to 1, this y equal to x square root x dy into dx. Then this is equal to 0 to 1. Then integrate this 10 y square by 2. Then the limits are y equal to x square, here y equal to root x into dx. Then if you substitute this 0 to 1, 10 by 2 5, y square x square root x, which is equal to 5 into integral 0 to 1 y equal to root x. Y square is x minus upper limit minus lower limit, y equal to x square, y square is x power 4. It should be multiplied by dx. Now we have to integrate this. This is equal to 5 into integral x dx minus integral x power 4 dx. Limit varying from 0 to 1. Here also 0 to 1. This is equal to 5 into x square by 2 minus x power 5 by 5. Limit varying from 0 to 1. This is 5 into 1 by 2 minus, instead of x you have to put 1 by 5. If you apply the lower limit 0, everything is vanished. This is equal to 5 into 10, and this is 5, this is 2. This 5 into 3 by 10 is 3 by 2. The double integral of dou n by dou x minus dou m by dou y into dx dy is equal to 3 by 2. You may expect the same result from the closed curve, m into dx plus n into dy. From the left hand side also, this is equal to c1 of m into dx plus n into dy plus c2 of m into dx plus n into dy. You may expect the same. For the c1 curve, the value of m 3x square minus 8y square into dx plus n value 4y minus 6xy. Verify this, the value of n 4y minus 6xy, n into dy. This is C1 curve, which is equal to what we have to evaluate. Now we should go to the C1 curve. This is C1 curve. For this C1 curve, the equation is, first blue curve is C1 curve, y equal to x square is the equation. Y equal to x square. equation is y equal to x square. Therefore, dy equal to 2x into dx. So in the above equation, we should change the values of y in terms of x. Now, the above equation is modified. Carefully we have to handle this. This is m into dx plus n into dy of c1. Because this is m, this is n. For the c1 curve, we have to express all the quantities in terms of x. First we should fix the values, then we will go to the limit. 3x square minus 8 into, what's the value of y? Y equal to x square. Y square is x power 4. We have to express y in terms of x into dx plus n. 4 into the value of y is x square minus 6x into the value of y is x square into dy. The value of dy is 2x into dx. Now we have to simplify this. This is equal to integral 3x square minus 8x power 4 into dx plus multiply 4x square into 2x, 8x cube. Here 6x cube into 2x, that is minus 12x power 4 into dx. Once again verify. 4x square into 2x, that is 8x cube. 6x cube into 2x minus 12x power 4. Entire is multiplied by dx. Now simplify this. 3x square minus 8x power 4 plus 8x cube minus 12x power 4. Entire is multiplied by dx, which is equal to 3x square minus 8 into 12, 20x power 4 plus 8x cube. Entire is multiplied by dx. Now we should come to the limits. The lowest value of x in the curve C1 is 0 and upper value of x is 1. See this, 0, 1. We have expressed x in terms of y square. The lowest value of y is 0 and upper limit of x is root y. Upper value of y is 1. So root 1 is equal to 1. So the limits are 0 and 1. Or directly we may go to this curve. No need to think about the closed region. We should think about the curve C1. The curve C1 starts from the point 0. The value of x is 0 and the maximum value of x is 1. We won't consider this region. We won't consider this equation. Just while dealing the curves individually, then take the starting point and end point. Starting point of the curve is 0 and end point of the curve is 1. So the lower limit of x is 0, upper limit is 1. Now integrate this. 3x cube by 3 minus 20x power 5 by 5 plus 8 x power 4 by 4. Now apply the limits 0 and 1, which is equal to, this is 1, 3 by 3, instead of x you have to put 1, this is 4, you may get 20 by 5 equal to 4 into 1 power 5, 1 plus 2, 4, 2 4s are 8 into 1 power 4, 1, 2. If you apply the lower limit, everything is vanished. This is equal to minus 1. So the m into dx plus n into dy for the region C1, for the curve C1 is minus 1. Now we have to find out the value of C2. M into dx plus n into dy for C2. This is equal to the value of m is 3x square minus 8y square. This is the value of m into dx plus n 4y minus 6xy into dy. For the curve C2. For the curve C2, what is the equation we have to see? For the curve C2, the equation is y square is equal to x. The equation is y square is equal to x. Therefore, 2y into dy equal to dx. In the above equation, instead of x, we have to put y square, and instead of dx, we have to put 2y dy. So we have to express all the quantities in terms of y. Say C2 m into dx plus n into dy is equal to integral 3 into, then x is y square, then x square is y power 4, x equal to y square, x square is y power 4 minus 8 y square into, instead of dx we have to put 2y dy plus 4y minus 6 into, instead of x we have to put y square into y into dy. Now we should come to our limits. We are talking about the C2 curve. The lower limit of C2 is 1, upper limit is 0, because the curve is approaching origin. So lower limit is 1, starting point is 1, end point is 0. So the lower limit is 1, upper limit is 0. This is equal to integral 1 to 0 multiply 3 into 2 6 y power 5, y power 4 into y power 5, 3 into 2 6 minus 8 into 2 16 y cube into dy plus 4y minus 6 y cube into dy. Now simplify. This is equal to 1 to 0, 16 y power 5 minus 16 y cube plus 4y minus 6 y cube. Entire is multiplied by dy. Then this is equal to interval 1 to 0, 6y power 5 minus 16y cube minus 6y cube, 22y cube plus 4y. Entire is multiplied by dy. Now integrate this. 6 into y power 6 by 6 minus 22 into y power 4 by 4 plus 4 y square by 2. Now we should apply the limit 1 to 0. This is y power 6 minus, we may write this one as 11 by 2 y power 4 plus 2y square. Now apply the limits 1 to 0. If you apply the upper limit, everything is vanished. Minus of, you have to apply the lower limit. 1 minus 11 by 2 plus 2. Now allow the negative sign to operate. This is equal to minus 1 plus 11 by 2 minus 2, which is equal to 11 by 2 minus 3. This is equal to 11 minus 6 whole divided by 2, which is 5 by 2. This is the value of m into dx plus n into dy C2. We know that m into dx plus n into dy c, which is equal to m into dx plus n into dy c1 plus m into dx plus n into dy c2. Then m into dx plus n into dy c1 value is minus 1. This is minus 1. M into dx plus n into dy c2 value is 5 by 2. If you sum up these two, it is minus 2 plus 5 whole divided by 2, which is equal to 3 by 2. We know that m into dx plus n into dy equal to double integral of dou n by dou x minus dou m by dou y into dx dy. This is for C, this is for R. For this problem, the value of dou n by dou y, dou n by dou x minus dou m by dou y, that integral value is 3 by 2. Then the value of m into dx plus n into dy is m into dx plus n into dy c1 plus m into dx plus n into dy c2, that is 3 by 2. So this is 3 by 2, this is also 3 by 2. Therefore the Green's theorem is verified for the given problem.